Hello there, welcome to my channel on chemistry lessons. This is an A-level chemistry video and it looks at using the IUPAC rules to name alkanes. Firstly though, if you don't subscribe, please do. Your support is very much appreciated, and please use the likes and comment features and let me know what you think. So by the end of this video, you're going to be able to name these 4 alkane molecules here, and I'm going to be using these as examples throughout the video, and at the end there's going to be a task for you to have a go yourself, and then I'll be able to go through those answers with you. Some basic rules to start with then. Whenever we draw organic molecules, carbon's always going to have 4 bonds. Whether that's 4 single bonds or a double bond and 2 single bonds, either way, it will always have a total sum of 4 bonds. And hydrogen will always have a single bond. Hydrogen only ever has 1 bond here. Now, when we name organic molecules, there's 3 sections to the name. To make this simple, I've put them in 3 different colours. So we have something at the beginning that we call a prefix, which is usually to name any side chains or the position of any side chains. And also if there's any other functional groups. So if we have 2 functional groups, you may have a prefix of one of the functional groups. And also some functional groups actually come as a prefix. And we'll see that when we look at haloalkanes. So that's the prefix, the bit at the beginning. The middle bit is known as the stem, and that's the longest part of the chain. So in this example, that pent, that's telling me that there's 5 carbons long. And then at the end, we have the suffix, which is usually identifies the functional group. In this case, ane. So because this video is only going to look at naming alkanes, we only have 1 suffix to worry about in this video. In the next video, we'll introduce more. So the suffix here is just ane, and that's telling us that the functional group is an alkane. And in terms of stem, we don't need to go past 10. And those are the different names for the different number of carbons in the chain. So for example, pent we've just seen is 5. If it was 8, we'd have oct. It'd be octane. And the prefix, I'm going to limit this to methyl, ethyl and propyl in this video, but there are numerous different prefixes we can have, but we'll be fine in this video and with BTEC Applied Unit 5 to just stick with these 3 for now. I will introduce more in future videos. So methyl, if a side chain is a CH3, we have a methyl prefix. And there's some examples, and again towards the end of this video we're going to look at drawing those 2 molecules there using the naming rules. So we're going to apply 3 rules when we name molecules. The first rule is to identify the functional group. Now we will be limited to functional groups in this unit, and in particular this video we're only looking at 1 functional group, which is alkanes. So currently we only have 1 suffix, which is ane. Again, I will introduce further suffixes in future videos. The second rule then is to identify the longest carbon chain. Now don't make the mistake and assume that the carbon chain is the one that runs straight through the middle, because some of the side chains might actually be longer or might increase the length of the chain, and we'll see some examples of that today. Third and finally then, once you've identified that longest chain, we need to circle any side chains from that chain. And once we identify those side chains, we need to name them and identify the position. The best thing to do then is to look at an example. So the first thing we must do is identify the functional group. Now we've already said here that the functional group is an alkane, because the only thing here is carbons and hydrogens. It's a hydrocarbon with only single bonds. So I've got to identify the longest chain. Don't just assume that the longest chain runs straight through the middle of the page, because it doesn't have to. So I'll show you what I mean. So that could be a chain. That's a chain of 4. But there's nothing stopping me with saying that's also a chain of 4. Now this here would just be a chain of 3. So we've got 3 options here. We've got the red, which would be 4. We've got the gold, which would also be 4. And we've got that purple, that would be 3. So I either go with the red or the gold, because they're both 4. Now it doesn't actually matter which one I go with. And to prove it, I will go with both of them. So I'll start with the red. Okay. Now if I start with the red, I either have to number them 1, 2, 3, and 4, but you can also number them backwards. You don't have to go left to right. So I could go 1, 2, 3, 4. So that's a 4 carbon chain and it's an alkane. So we're going to start with the stem bute, and I'm going to use the suffix ane because it's an alkane. So I've now identified this part of my molecule. Does it have a side chain? Yes, it does. The side chain is here. What is the side chain? The side chain is a CH3 group, which is a methyl. So it's going to be methyl butane. In terms of the position, I've got two possibilities here. I've got two options. It's either 2 or 3. It depends on which way I've numbered the chain. And the rule is you have to go with the lowest number. So this would be called 2-methyl butane. And that's if I go with the red chain. What will happen if I go with the gold chain, which was this one? Well, it's still bute, so it's still butane. This time, though, I've taken account of this part of the molecule, so it does have a side chain. It still has a side chain, which is this chain here. And it's still a methyl, so it's still methyl butane. Let's check the numbers. 1, 2, 3, 4, or 1, 2, 3, 4. Now I have to go with the lowest number, so it's 2. 2-methyl butane, which is the exact same name as I got for the red chain. So just prove that it doesn't matter which direction or which chain we pick, as long as it's the longest chain. Next example then. So number 1, identify the functional group. Well, again, it's just a hydrocarbon with only single bonds, so it's an alkane. So we already know that the suffix is going to be ane. Now I need to identify the longest carbon chain. 1, 2, 3, 4. Or we could go 1, 2, 3, 4. Or we could go 1, 2, 3, 4, 5. Now I don't think I can get a longer chain than 5 on this molecule. So I'm going to go with 5 being my longest chain. And that was this way here. Again, I can go 1, 2, 3, 4, 5. Or I could have gone 1, 2, 3, 4, 5. It is important that we're aware that we can number them either direction. So that's 5. So that's pentane. So for the pentane, I've taken account of these part of the molecules here. There is a side chain, look. Up the top here, there's a side chain of a CH3. That's a methyl. So this is methyl pentane. What's the position of the methyl? It's either 3 or 3. So it doesn't actually matter. It's 3-methyl pentane. Next up then, identifying the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Can I beat 6? I don't think I can. So my longest chain is 6. And that was this way. So I've got to number them 1, 2, 3, 4, 5, 6. And I can number them reverse as well. 1, 2, 3, 4, 5, 6. So that's going to account for that part of the molecule. So that's 6. So that's going to be hex, ane. So the stem is hex and the suffix is ane. Does it have a side chain? Yes, it does. This is a methyl side chain and it appears on either the 3 or the 4. I've got to go with the lowest number. So 3-methyl hexane. Final example then. Right, now this is definitely a strange one, which is why I've put this in, and it might actually be beyond your Unit 5 specification, but I think we're best off being over prepared than under prepared. So this is a carbon chain of 4, but it's a cyclic 4. Okay, so it's 4, which is bute, and it's an alkane, which is ane, but we call this cyclobutane. It's a cyclic 4-carboned alkane, cyclobutane. So what I'm going to suggest you do for this page is I'm going to suggest you pause the video and you try and name these 3 yourself, and when you're ready to hear the answer, unpause the video. Okay, let's start with this one up on the top left. I've identified the longest chain as 4, so that's butane. It has 2 side chains and they're both methyl, so I'm calling this dimethyl butane. What's the position? Well, let me number them. 1, 2, 3, 4, or 1, 2, 3, 4. So it's dimethyl 2, 3 dimethyl, or 2, 3 dimethyl. So it's actually the same name. So it's 2, 3 dimethyl butane. Okay, let's have a look at this one here. So 1, 2, 3, 4. So that's butane. This time there's a methyl side chain, so it's methyl butane. What's the position of our methyl group? 1, 2, 3, 4, or 1, 2, 3, 4. So it's either 2 or 3 methyl. I have to go with the lowest number, so it's 2 methyl butane. Final example then, or last question down the bottom here. 1, 2, 3, 4, 5, and be careful, this one at the top is also part of the chain. It's tempting here to stop at 5, but actually the chain continues up on the top. So this is hexane. And there's a methyl group on the hexane, so it's methyl hexane. Where is it on the chain? We've got 1, 2, 3, 4, 5, and 6, or 1, 2, 3, 4, 5, and 6. So it's either 3 or 4, we call the lowest number, 3 methyl hexane. So the last task then is we're going to do it in reverse now. So we've been given the names, and these were the names of molecules we saw in the earlier part of the video. I'm going to suggest you pause the video, you try and draw these 2 from the names, and when you're ready to see the answers, unpause the video. Okay, so the first one then, I'm going to draw my stem, so pentane. I'm going to draw 5 carbons in a row. 1, 2, 3, 4, 5. And then there's a methyl group on the number 2. So I'm going to draw CH3 on that number 2 there. And then I'm going to complete the molecule by drawing all the other hydrogens in. And it's a good check at the end to make sure that you've only got 1 bond on every hydrogen and that every carbon has 4 bonds. Because it's quite easy to miss a bond off somewhere. So double check by counting your bonds. Next one, 2,2 dimethyl 3-ethyl pentane. That's a bit of a mouthful. Right, so pentane, 1, 2, 3, 4, 5. 2,2 dimethyl, that means there's 2 methyls on the number 2. That's CH3 groups. And there's a 3-ethyl. Now an ethyl we haven't seen yet, although we did see it in the naming of the prefixes here. An ethyl is a CH2 CH3. So it's a CH2 and a CH3. So this is quite a complex one to draw. Now I need to finish the molecule off by making sure all my carbons have got 4 bonds. Need some more space down the bottom there. There we go. So that's a CH3 there. Just making sure I'm drawing all the bonds on. That's a CH3 there. So that looks quite impressive. That's a 2,2-dimethyl, 3-ethyl pentane. But I'm just applying those rules. And that's the end of this video then. Hopefully that was useful. If it was, please let me know through the likes and the comments and share it with your friends. If it wasn't, don't tell anyone. Either way, thanks for watching. Good luck with your exams.